So okay, so we will start in 2 minutes. Okay, start in 2 minutes. I hope I am audible. Okay, so good morning, everyone. Hello. Good afternoon, everyone. Welcome to week 5 of problem solving session for course NPTEL-ME111, which is applied numerical methods. So till week 5, what we have covered, we have seen the how to solve a nonlinear equation. Just give me 1 second. I hope I am audible. If I am audible, please reply on the chat box. If I am audible, please reply on the chat box so that I can continue. Okay. And please send your email ID in this chat box so that if there is anything, I can mail you directly. Okay, thank you. So we will start now. So in this core applied numerical method, ME111, first we have seen why numerical method is important. And we have also seen there two methods to solve a nonlinear equation, how to find a root of nonlinear equation. There we have seen bisection method and Newton-Raphson method. Then after that, in second week, what we have covered? I think in week 2, what we have covered? It is small. Okay, so in this week, we will cover the calculus part. Last week, we have completed the linear algebra part. In the linear algebra part, what we have seen? We have seen how to solve equation AX equal to B type of problem, which is system of linear equations. So there we have seen Gauss elimination method. Then we have seen LU decomposition method. Then we have seen these two methods are called direct type of. And then we have seen also here iterative type of solver. In iterative type of solver, we have seen Gauss-Seidel, and Jacobi iteration. Then after that, what we have covered? We have covered Ax equal to lambda x type of problem, which means what? We tried to find the eigenvalue and eigenvector of a square matrix, right? There we have seen power method, and inverse power method. This inverse power method can be solved two types: without shifting and with shifting. Okay, so by using this power method, we are able to find the maximum eigenvalue and its corresponding eigenvector. By using the inverse power method, we are able to find the minimum eigenvalue. Okay, the minimum eigenvalue we are able to find. And then by using the shifting method, we can find the rest of the eigenvalues of a square matrix. Okay, so now from linear algebra, we move towards the calculus. Okay, so now we'll see the numerical methods that are important related to calculus part of mathematics. Okay, I hope I am audible. So what is the difference here? So whenever we go for analytical solution, or we say calculus analytically, we have a continuous domain and range of a function. Okay, but in case of numerical methods, or in case of when we go for numerical solution, we have only a discrete set of domain. We know the function and its value only at some discrete points. Okay, so what we will cover this week, the instructor had covered this week. First, the interpolation. There he has covered about the mostly the polynomial interpolation. Then numerical differentiation. In numerical differentiation, he has covered about finite difference method. Okay, so let us go to interpolation part. Okay, so if we see interpolation, here we will see only polynomial type of interpolation. There are other types of interpolation as well, but in this course, we will see only polynomial type of interpolation. Okay, so since we have function and its value only at discrete point, so here let us assume that we have n+1 discrete points. N+1 discrete point means what? We have function and its value, and this x at n+1 point. We know function value at n+1 point. Okay, dot x and y. Okay, so what we want to do? We want to find a polynomial of an order that passes through this n+1 points. Okay, this n+1 discrete points. This is what we try to do in polynomial interpolation. So in general, how we can express a nth order polynomial? We can express a nth order polynomial y equal to some polynomial of nth order will be equal to a0 plus a1 x plus a2 x square plus a3 x cube plus dot a n x to the power n. Okay, this is my nth order polynomial. So here, how many unknowns are there? This is the unknown. A1 is unknown. A2 is unknown. Similarly, an is unknown. So we have n+1 unknowns here. Okay, n plus unknowns, and how many points we have? We have n+1 point, right? If we have n+1 point, if we have n+1 point, we can directly satisfy this n+1 point to this equation. So if I put xi, yi, where I goes from 0, 1 to n in the above polynomial equation, so what will it? We will get, if I put x0, y0 in the above polynomial, first equation we will get a0, a1 x0 plus a2, a2 x0 square plus similarly an x0 to the power n. This will be equal to what? This will be equal to y0. This is my equation 1. Similarly, if I put x1 and y1 in the equation, what I will get? I will get a0 a1 x1 plus a2 x1 square plus an xn to the power n. That will be equal to yn. This is my equation 2. Similarly, in all equations, if I put the nth equation will look like this. Simply x will be replaced by xn and y will be replaced by yn. So if the same this set of n equation I represent in terms of matrix notation, this is what I will get. This is my coefficient matrix, this is my unknowns, and this is my right hand side of the system of linear equation. These are the linear equations. Since x0, x1, x dot dot xn, these are known, and y, y1, y0, y1 dot dot yn, these all are known. So this is nothing but a system of linear equation. This system of linear equation we can solve. We can solve by using any linear solver. Okay, we can solve using any linear solver. So this coefficient matrix is known as Vandermonde matrix. Okay, this matrix which is comes like 1 x0 square x0 cube dot x n x0 to the power n. Then in second note 1, then x1, then x1 square dot x1 to the power n. In the nth row 1 xn, then xn square dot xn to the power n. This coefficient matrix is known as Vandermonde matrix. If you find the determinant of this matrix, it will come like that. That will be the multiple of xj minus xi, where I and j goes from 0 to n, and I is not equal to j. So if I is not equal to j, in that case, our matrix will not have a zero value. This is what? This is an invertible matrix or non-singular matrix, which means what? If we are able to find the inverse of this matrix, we can solve this problem and get the coefficient a0, a1 dot an. Okay. But what is the problem with this Vandermonde matrix? The problem of Vandermonde matrix is that this is not a well-behaved matrix. What do we mean by well-behaved matrix? Suppose if we choose xi's are very close to each other, means we have very fine grid, then what will happen? Then these differences will be very small. So determinant will be what? Very small. Then its inverse will be very high. In that case, if we make a small change in xi and yi, that will lead to the large change in the solution. So my solution will not be stable. It will be very unstable type of solution. So that's why this Vandermonde matrix is called not a well-behaved matrix. Okay. So that's why we do not go to inverting this Vandermonde matrix. Rather than we use some special type of polynomials to find the interpolating polynomial, and these polynomials are called interpolating polynomial. Okay. So now we'll see some special type of interpolating polynomials. Okay. The first of this type interpolating polynomial is Newton's interpolating polynomial. Okay. Newton's interpolating polynomial. Here we assume y, which is nothing but a function of f, is equal to b naught plus b1 x minus x naught plus b2 x minus x1 multiplied by x minus x naught plus dot 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 bn. Pi means a multiple of x minus xi, where I goes from 0 to n. So you have seen this is a special kind of polynomial. Okay. Now we wish to find these unknowns, this coefficient b1, b2 dot bn. How we can find this? We have n plus 1 discrete points. Okay. This we have. Simply we will put this in equation one by one and get the value b naught b1 like that. If you do that, what value we will get? We will get b naught equal to y naught simply. And what will get b1? B1 will comes as this. This is called difference. This will come as forward difference, which will be equal to, which is represented as f in the third bracket or in square bracket x1 x1 comma x2, which is equal to y1 minus y2, sorry, y1 minus y0 divided by x1 minus x0. Okay. Similarly, if you will find b2, the b2 will come like that. That is represented as f x2 comma x3 x2 comma x1 comma x0, which will be equal to the difference of differences. Okay, so it will comes like that: y2 minus y1 divided by x2 minus x1 minus y1 minus y naught divided by x1 minus x naught whole divided by x2 minus x0. Okay, this look complicated, but we will solve a problem there. We will see it is very easy to compute. Okay, similarly other also you can find. So what we have did in this here, what we have did, we have changed Van der Waals matrix to a lower triangular matrix. And you know how to solve lower triangular matrix? We can directly do forward substitution, substitution to solve the lower triangular matrix. Okay. So in the first row only one, then all are 0. Second row 1, then x1 minus x naught, then next all other terms are 0. In the last row all terms will be there. First one, then xn minus x naught, then xn minus x naught, xn minus x1 multiply similarly like that. Okay. So this is a lower triangular matrix. Then you can easily find the values of this coefficient b1, sorry, b0, b1, b2 dot dot bn by doing forward substitution. Okay, fine. This is what method called? This method is called Newton interpolating polynomial method. Okay. Now the second method is also a very important method. This method is known as Lagrange interpolating polynomial method. Okay. In Lagrange interpolating polynomial method, we try to represent y, which is a function of x, as summation of I equal to 0 to n L I of x multiplied by f at xi's. This L is what? This L is called as Lagrange polynomials. Okay, this is called Lagrange polynomial. The whole derivation has been shown by the instructor in the lectures. So if you want to see the derivation, you can go and watch again the lecture. Okay, here we will see directly what is the formula of Lagrange polynomial. The formula of Lagrange polynomial, Li is equal to multiplication of j equal to 0 to n, j not equal to I. If we want to find the Lagrange polynomial ith, that will be equal to j equal to 0 multiplication of j 0 to n, j not equal to I, x minus xj divided by xi minus xj. Okay. So suppose if we have 4 points, and I want to represent L0, then L0 will be equal to what? Since I have written here 0, so it will not include 0 here. So it will start from J will start from 0, but here we will not have the 0th one. So x minus x1, x minus x2, x minus x3 whole multiply divided by the same term, but x will be replaced by this number. So x0 minus x1, x0 minus x2, x0 minus x3. Suppose same I want to write L1. What will be the value of L1? X minus x0, x minus x1. Since one is here, so 1 will not be here. So I will remove this one and directly go for 2. Then x minus x3. Same denominator will come in the denominator, but this whatever the term is here, I will directly put here. So x1 minus x0, x1 minus x2, x1 minus x3. So this will be my L1. Similarly, if I want to write L2, then what will be the L2? So x2 will not be there. In place of x2, x1 will come. Okay, and in the denominator, in place of x1, there will be what? There will be x2. Okay, this will be my L2. Fine. Everything clear till yet? Please respond. Okay. So these two methods has been discussed in week 5 for interpolation. The first method is Newton's polynomial interpolation. Second method is what? Second method is Lagrangian interpolating polynomial method. Okay. So if we are doing the polynomial interpolation, there will be some error involved. So this error expression comes at, suppose I want to represent some function f as a interpolating polynomial, then this error will come as f n time differentiation in that interval some xi divided by n factorial, then this product of I goes from 0 to n x minus xi. So from here what we can see, this error is proportional to function's derivative n plus 1th time derivative. Okay, so what we have seen, the error is proportional to the n plus 1th time derivative of the function. Okay, which means what? This error in the polynomial interpolation may become high when function's derivative increases with order n. So suppose we have a function whose derivative value will increases as we do higher order differentiation. Okay, in that case, representing the function into a polynomial form will lead to higher and higher error. Okay, so in that case, we need to choose these discrete points x0, y0, and x1, y1 like that, these points carefully. We need to choose these points carefully such that these points are not close to the points where the derivative values are high. Okay. So this is all that has been discussed by the instructor for interpolation. Okay. Now what we will do, we'll try to solve some problem. Then we will come back here and discuss about the numerical differentiation. Okay. There we will discuss finite difference method. Okay. So now we'll directly go and solve some problem. Okay. So this is the first problem that we have. So please try to solve this problem and if possible, post the answer in the chat box. Okay. So suppose we have a function y equal to x to the power x. Okay. And we want to find its first order derivative, means dy by dx. You try to solve. I will also solve here. And if you have solved, you please post the answer in the chat box. Okay. So what will be the solution of this problem? Since y equal to x to the power x, I simply take log on the natural log on both sides. So ln y will be equal to what? X ln y. Now what I will do, I will differentiate this function with respect to x. Okay. If I differentiate, it will come 1 upon y, the differentiation of y, ln y, then dy by dx. In the right hand side, what it will be? Sorry, here it will be ln x. So what will be the right side? First function, differentiation of second, plus second function, differentiation of first. Okay. So it will come dy by dx as y multiplied by 1 plus ln x. What is the value of y? We will put simply here. So dy by dx, that will be equal to x to the power x 1 plus ln x. Okay. So this will be the answer. Good. Good. So this is the second problem. In the second problem, what we are trying to do, we are using polynomial interpolation to exactly fit y equal to a naught plus a1x plus a2x square through data y equal to at x equal to 1 is 1, y at x equal to 2 is 4, and y at x equal to 3 is 27. So what we are trying to find? We are trying to find a0, a1, and a2. And we want to round off our answer to 1 decimal places. Okay. So we can use three methods. Now, the three methods we had discussed. First method is what? First method is Vandermonde method, matrix method. There we directly try to find the inverse of the Vandermonde matrix. Then what we can do? Then we can use Newton's polynomial method to find out this coefficient. Then at last we can do the Lagrange interpolation method to find this a0, a1, a2. Okay. Here you will see the answer will come by all three methods same. Okay. So all three methods are same, but one has advantage. These two last two methods are advantageous compared to the Vandermonde matrix method. Okay. So let us try to solve this problem. You also try to solve this problem, then post the answer in the chat box. Or else you see here, I will explain, then you solve next problem. Okay. So what we have here, we have here x0, y0 as what? 1, 1. Okay. Similarly, we have x1, y1. This is what? 2, 4. Similarly, x2, y2 that we have, this is equal to, this is nothing but what? This is 3 and 27. No? Okay. Now what we'll do? We have y equal to what? We have y equal to a0, a1x plus a2x square. Okay. Now we will put this x0, y0, x1, y1 on our equation. Okay. Okay. So we'll put the value here and we'll try to. So here y0 will be what? Y0 will be equal to a0 plus a1 x0 plus a2 x0 square. That will lead to y1 y not equal to 1 a naught plus a1 plus a2. Okay, this will, if I put x0 as 1 and y0 as 1. Okay, this is my equation. Similarly, y1 will be equal to what? A0 plus a1 x1 plus a2 x1 square. That will lead to 4 equal to a0 plus a1, no, 2a1, x1 equal to 2, so it will be 2a1 plus 4a2. This is my equation 2. Okay, then y2 will be equal to a0 plus a1 x2 plus a2 x2 square. Y2 is 27 and x2 is what, 3. So this will be a0 plus 3a1 plus 9a2. This is my equation 3. Then what we will do, we'll simply subtract 1 from 2. It will lead to 3 will be equal to a1 plus 3 a2. Okay, then simply 3 minus 2 we will do. This will lead to what? 23. That will be equal to a1 plus 5. Okay, it will be 5 a2. Okay, now whatever we got, we will subtract this. So we'll get minus 20 will be equal to minus 2 a2. This will lead to a2 equal to, this will lead to a2 equal to 10. Okay. Okay, a2 equal to 10. Now we will try to find this a1. Okay, so from here a1 will come as 30. This will become 30. Other side it will go, it will become minus 27. Okay, so a1 will be equal to minus 27. Then a2 will be what? A1 plus a2 plus a3 is 1. So a0 will be equal what? A0 will be equal to 18. If you sum a1 and a2, it will give us minus 17. So I will, if I sum 18 in that, I will get 1 as a1 plus a0 plus a1 plus a2. This is the value. Okay, fine. So maybe I write directly. I should write directly these values. So if you do the calculations, whatever the values we have got, I will simply write here for our reference. Okay, for our reference, what is the value of a1, a0 and a2? So 18. Okay, what is the second value? Minus 27. And what is the third value? 10. So this is what we have got here. Okay, and now I will simply erase this. Not we, what we will do now. Now what we will do, we will try to solve this problem using the Newton interpolating method. Okay, fine. So in Newton interpolating polynomial method, I simply make a table like that. Okay, so this is my I0, 1, 2. Okay, then what I will write? I will write as xi. Okay, then yi. This is my table. Okay, so what will be my function value? Y will be equal to, if you remember from Newton's, here we have discussed now, somewhere we have discussed, here we have written a value. This is the value now. So our function will be what? Function will be y0 plus f of x1 x0 multiplied by y1 plus f of what? Sorry, this will be what? This will be x minus x0. Then what? Then x2 x1 x0 x minus x0 x minus x1. Okay, this is my function. So if I am able to find these values, this value and this value, I can able to find out the polynomial. Okay, so what is the values? 1, 2, 3 corresponding y values, 1, then 4, then 27. Okay, then now we will try to find f of x I plus 1 comma xi. Okay, this is what we will try to find. Okay, this will be equal to what? So here if I want to find, so it will be equal to this value y0, sorry, y1 minus y0 divided by x1 minus x0. So y1 what? 4 minus 1 divided by 2 minus 1. This will lead to 3. Okay. Similarly here, this will be equal to 27 minus 4 divided by 3 minus 2. This will lead to 23. So if I now try to find x of I plus 2, x of I plus 1, x of I plus 1, comma x of I. Okay, if I want to find this will be equal to what? This will be equal to this value minus this value. So 23 minus 3 divided by this value and this value. So 3 minus 1, that will lead to 10. Okay. So simply I will put the values here. So first value y will be equal to this value will come, then this value will come, then this value will come. Okay. So 1 plus 3 multiplied by x minus x naught plus 10 multiplied by x minus x naught is what? X naught is what? 1. X1 is what? 2. If you solve this further, 1 plus 3x minus 3 plus 10 multiplied by x square minus 3x plus 2. Okay, if you multiply by 10, it will be 10, 20, 30 minus 30x plus 20. Okay, so from here up, if I get y will be equal to what? This will be equal to 18, 21 minus 3, 18. X will be what? Minus 30 plus 3 minus 27 x plus 10 x square. Okay, so this is what we have got here. Clear? Okay, so from here if you see, what is my a naught? 18. What is my a1? Minus 21, 27. What is my a2? This is what? 10. Okay, this is the same value that we have got using the Vandermonde matrix or directly solving the problem. Okay. Okay. Now the same problem we wish to solve using Lagrange interpolation method. The answer will be the same, but let us see how it will go. So if I write Lagrange interpolation method, it will be equal to I goes from 0 to n Li x multiplied by f of x I. Okay, which means here in this case it will be equal to, since we have 3 points, it will be equal to L0 x multiplied by y0 plus L1 of x multiplied by y1 plus L2 of x multiplied by y2. Okay. So if I want to find Li, so Li is represented as multiplication of j goes from 0 to n and j not equal to I. Okay. And the formula is x minus xj divided by xi minus xj. Okay. So simply if I write here L0 of x for our case. Okay. So it will come as x minus x1, x minus x2. Okay. Divided by x0 minus x1, x0 minus x2. Okay. So L0 of x will be equal to x minus 2, x minus 3. x2 is 3. So x0 is what? 1. So 1 minus 2, 1 minus x2 is 3. So it will be 3. So it will come as minus 1. And this will be what? Minus 2. So that will be multiplied. That will give me 1 by 2 x square minus 5x plus 6. Okay. Similarly, if I will find L1 of x, L1 of x will be equal to what? L1 of x will be equal to x minus x0, x minus x2 divided by x1 minus x0. Then what? x1 minus x2. So x minus x0 is what? x0 is 1. X minus x4, x2 is what? 3. Divided by x1 is what? x1 is my x1 is 2 and x0 is 1. Okay, then x1 is 2 minus x2 is 3. This will lead to minus of x square. This is minus 1, this is minus 1, so minus 1 will come. If you multiply here, 4x plus 3. Okay. Similarly, if I will find L2 of x, that will be equal to x minus x0, x minus x1 divided by what? x2 minus x0 and x2 minus x1. So 3 minus 1, 3 minus 2. Here x minus 1, x minus 2. This will lead to 1 by 2 x square minus 3x plus 2. Okay. Now if I write the function, the y will be equal to what? y0 is what? y0 is 1. 1 multiplied by this whole term. 1 by 2. 1 by 2 x square minus 5x plus 6. Okay. Plus y1 is what? y1 is 4. 4. Then the whole term will be negative since L is my negative. X square minus 4x plus 3. Okay. Then what? y2 is what? 27. 27 divided by 2. X square minus 3x plus 2. If you multiply it, first we'll take 1 by 2 as common. Then x square minus 5x plus 6. It will be 8x square. 8x square minus 32x plus 32x minus, oh sorry, right, 24, 27x square minus 27 multiplied by 3 times 81 x minus 54. If you solve this, it will come as same. 18 minus 27x plus 10x squared. How it will come? See here. This is what? Minus, it will come 15. 15 minus 5. You will find the same value, no? Okay, fine. Please respond. So this, and this will 28, 28 minus 8, that will be 10 divided by 3. Huh? Okay. So you see, you have found the same value for all three methods. Okay. So now you try to solve this problem and post the answer. I will wait here for some time. The same problem is there, only the values are different. At y at x equal to 1 is 1, y at x equal to 2 is 6, and y at x equal to 3 is 29. Now you try this problem using Newton polynomial method. Okay. And please tell me the value of a0, a1, and a2. Okay. Since we do not have any programming assignment this week, we do not have to write any computer program in this problem solving session. I am going little bit slowly. Okay. You try to solve, try to make this like this table, a table like this, and show me the value if you have found. Post the value in the chat box. So here what we have 3 points, 0, 1, and 2. X0 is 1, x1 is 2, and x2 is 3. y0 is 1, y1 is 6, and y2 is 29. So simply the difference of this divided by difference of this will lead to difference f I plus 1 comma I, that will 5 and 23. Now if we take the difference of this and this and divide by difference of this point, this and this, then it will lead to what? Then it will lead to value 9. Okay. Now simply you put these values, y0 is 1, so put here 1. Then this f of x1 in third equation, x1 comma x0, that is 5. Then 5, x minus x0 is 1, so did simply 1. Then x minus x0, x minus x1, put the value, and this value you put here, then you will get the expression for y. This expression is y equal to 14 minus 22x plus 9x square, which means what? A0 equal to 14, A1 equal to minus 22, and A2 equal to what? A2 equal to 9. Please post the answer once you got. Have you found the answer? Okay, okay. Please solve. Good, good, very good, well done. So now we have seen the interpolating polynomial method. Okay. So now we will move towards numerical differentiation. Okay. There we will discuss about finite difference method. Okay. Finite difference method. So what we have, if you remember, the formula of derivative from the first principle. So this y prime, if I want to find y prime at some point x equal to x naught, this can be represented as du upon dx at x equal to x naught. This is nothing but a slope of y, so of sorry u at x equal to x naught. If I write from first principle its value, that will be equal to limit delta x tends to 0 u at x naught plus delta x minus u at x naught divided by this delta x. Okay. And if I write the r LHD, means the limit from the left hand side, this will be equal to u at x naught minus u at x naught minus delta x divided by delta x. Okay. So this is what the formula of derivative or differentiation. Okay. From the first principle. Now in numerical methods, we do not have a continuous domain. Rather than we have a discrete domain. Discrete domain is what? We have the values at some discrete points only. Okay. These discrete points, we have the value of function, and so we want to find out the derivatives at this discrete point. Okay. So if we assume for the time book, we assume this is a uniform grid. Uniform grid means what? Means these difference all are same. All are same. This delta x equal to, suppose this is my ith. So this will be what? I plus 1. This will be what? I minus 1. This will be what? I plus 2. Okay. So this delta x will be equal to x of I minus x of I minus 1. That will be equal to x of I plus 1 minus x of I for every I. Okay. So simply if I write u at x equal to xi as ui, and u at x equal to xi minus 1 as u of I minus of, similarly means what? The suffix at x simply put at u. Okay. If I write like that, the derivative can be expressed at du upon dy, du upon dx, that will be equal to del u upon del x at x equal to I. So suppose this is my I. So here if I want to find, I can find by taking the difference of these 2 points, or these 2 points. Okay. If I take these 2 points, this is called backward difference. If I take this point, this is called as forward difference. Okay. So simply du upon dx will be equal to what? Ui plus 1 minus ui divided by delta x. This is what? Forward difference. Similarly, if I want to write backward difference, that will be equal to what? ui minus 1 divided by delta s. This is backward difference. And this method, the method of writing differentiation in these fashion, in terms of difference at discrete point, is known as finite difference method. In finite difference method, what we try to do, we have the function's value at discrete point. So we write the differentiation as a term of, as a difference of function at discrete point. Okay. That's why this is called finite difference method. Okay. This finite difference method can be visualized using the Taylor series expansion. Okay. So now we'll go to Taylor series expansion to discuss it further. Okay. And there we will see the truncation error also. So suppose I want to write ui plus 1. Ui plus 1 is what? If I write I plus 1 is what? Nothing but u at I. No, sorry, u at x equal to I plus 1. And this is what? This is nothing but u at x equal to xi plus delta. Okay, so u at x equal to xi plus delta, this can be represented using Taylor series expansion. So what will be the value? Ui plus 1 will be equal to ui plus derivative plus delta x multiplies u prime plus delta x square divided by 2 factorial ui double prime plus delta x cube divided by 3 factorial ui triple prime plus dot dot dot. Like that we can represent. Okay. Similarly, if I want to represent ui minus 1, then it will be equal to what? Then it will be equal to ui minus delta x ui prime plus delta x square divided by 2 factorial ui double prime minus delta x cube divided by 3 factorial ui triple prime plus higher order terms. Okay. If I want to find out the ui prime using the forward difference method, so simply what I will do, by using this equation, the above equation, I can find just give me 1 minute. Okay. So I can directly find ui plus 1 minus ui, that will equal to delta of x multiplied by ui prime plus delta x square upon 2 factorial ui double prime plus higher order terms. Okay. Simply now divide the whole equation by delta x. That will lead to ui prime that we wish to find, that will be equal to ui plus 1 minus ui divided by delta x plus this divided by 2 u double prime I plus higher order term. Okay. Now, if I neglect these terms, what will be the ui from forward difference? I will get ui plus 1 minus ui divided by delta x. Okay. This is what I will get. And what is this? This is what I have truncated, no? Truncated. This is what I have truncated. No? So that's why this is called truncation error. This comes from the truncating the Taylor series or by neglecting some term in the Taylor series. Okay. So this is what, if my delta x very small, these higher order terms which are present, that will be very small compared to this term. Okay. So this whole I can represent as order of delta x. This is what order of okay. This means what? This means what? This means what? Forward difference at first order accuracy. Okay. Means it says the error of delta x order. Fine. Now similarly, if I go for backward order, I can get ui dash, that will lead to ui minus 1 divided by delta x. Okay. it will also have order of delta x. Okay, error of order of delta x. This doesn't mean that it will have error of delta x, but it means that once I will decrease the size of the grid, my error will decrease with order delta x. Okay, or if I increase the size of the grid, my error order will increase as delta x order. Okay, now this is the backward difference. Okay, this is what backward difference. Similarly, I can go for central difference. Central difference means what? If I has I here, okay, if I has I here, then I will take I as a center and I will use difference of I plus 1 and I minus 1. Okay, how I can do this? I will write the Taylor series at I plus 1 and I minus 1. So ui will be equal to what? Ui plus 1 will be equal to ui plus delta x ui prime plus delta x square upon 2 factorial ui double prime plus delta x cube upon 3 factorial ui triple prime dot. Similarly, if I try to write ui minus 1, that will be equal to what? That will be equal to ui plus 9, that will be minus delta x. The odd term will be negative and even term will be positive. Ui prime plus delta x square divided by 2 factorial ui double prime minus delta x cube divided by 3 factorial ui triple prime plus dot. Okay. Now, if I simply subtract these two equations, what I will get? Ui plus 1 minus ui minus 1. This will be equal to 2 delta x ui prime. Now, if you see this term, oh, sorry, this term and this term is same. If I will subtract, this will be cancel. So what will be the value? This will come as 2 delta x cube divided by 3 factorial ui triple prime plus some higher order term. Okay. Now from here, if I find this ui prime, this will be equal to ui plus 1 minus ui minus 1 upon 2 delta x plus 2 is gone. So this will be equal to minus delta x. If I divide this equation by delta x, then this will be delta x square upon 3 factorial ui triple prime plus higher order term. Okay. Okay. So this is what I will truncate. Okay. So I will get u prime at I, that will be equal to ui plus 1 minus ui minus 1 divided by 2 delta x. This is my central difference formula for the derivative. Okay. This will be the formula. And what will be the order of this order of truncation error? Order will be delta x square. Okay. Fine. Good. Okay. Now similarly, you can write for ui double prime as forward difference as backward difference. Okay. and as central difference. Okay. You can also write this first order derivative u prime at I as 3 point forward or backward difference that will lead to truncation error order as delta x square. Okay. This all has been covered by the instructor in the lectures. Okay. So do you want me to do any of this? Whatever I have written here, this one or this one. If you want, I can do, or I can directly write the formula. Okay, it's clear. Okay, fine. So suppose by central difference, I write this formula of second order derivative. That will come as ui double prime, that will be equal to ui minus 1 plus 2ui, sorry, minus 2ui plus ui plus 1. Here you will need for first order derivative, you need 2 points. For second order derivative, you will need 3 points. Okay. So minimum 3 points. You can take for more points to go for higher order of accuracy for the truncation error. Okay. Divided by delta x square. This is what we'll get, and we will get some order of delta x square. Okay. This is order of truncation error. Okay. What this will involve? This will involve, if I will write, this will involve ui plus 2 and ui plus 1 and ui. This will involve ui minus 2, ui minus 1 and ui. Okay. Now we'll solve some problem. Okay. Now we will try to solve some problem based on these formulas. So this is the problem we have. Okay, so please find out this value of this problem, whatever we have. For a certain function y equal to, f of x such that y at x1 equal to 1, y at x equal to 2 equal to 6, and y at x equal to 3 equal to 29. We want to find dy by dx at x equal to 2, means at the central point. We have 3 points and we want to find at central point. Okay, by using forward difference or backward or central difference, all three, we want to find out the derivative. Okay, so if we want to solve this problem, so suppose I want to go for forward difference first. So I want to find here. If I make the stencil, this is my what? This is my I. This is my I minus 1. This is my I plus 1. Here what is x? X equal to 1, x equal to 2, x equal to 3. At this point, I have y equal to what? Y equal to 1, y equal to 4. Sorry, y equal to 4, not 6, no? 6. Y equal to 6 and y equal to 29. Okay. So, from here, if I want to find ui prime, this will be equal to what? Ui plus 1 minus ui divided by delta x. Here delta x is what? Or this may not be always uniform. So this will be what? X of I plus 1 minus x of I. Okay. So this value is what? Its value is what? 29. So this is not u. This is why 29 minus 6 divided by 3 minus 2. This will be equal to what? 23. I hope so. Similarly, for backward difference, y prime at ith location, this will be equal to y I minus y I minus 1 divided by x of I minus x of I minus 1. Okay. So this is equal to 6. This is equal to 1 divided by what? Divided by what? Divided by 2 minus 1. This will lead to 5. Okay. Now central difference. This will be equal to y I plus 1 minus y I minus 1 divided by x I plus 1 minus x I minus 1. Okay. So this is what? 29 minus this is what? 1. This is what? 3 minus 1, 14. Okay. The same answer I hope you would have also got. 23, 5 and 14. Okay. Fine. Clear? Okay. Now we'll move towards the last problem of the today's session. This is the problem that we have. Assuming uniform grid, we want to find the expression for the terms a0, a1, a2, a3 for this second order derivative using 4-point backward difference. Okay, 4-point backward difference we will use to find out the expression for 4-point backward difference second order derivative using finite element method. And for that we need to find a0, a1, a2, a3. This is called 4-point backward difference. Means what? Second order derivative by using 4-point backward difference scheme. Okay, this is what it will be called. Okay, now we used to find a0, a1, a2, a3. So you see there, this is the normal procedure. Na? This kind of problem will come in your exam. Na? So you see here. So what I want to find. So rather than I write y, I will writing here u. Okay, u. Or I can write y also. But suppose I am writing y, I am replacing y to u. Okay, simply here I am replacing here y to u. Okay, this is what we want to find. Okay. So we wish to find ui double prime using 4-point backward difference. And also we will find out its order, okay, its truncation error order. So for that I need to write first ui minus 1. So ui minus 1 will be equal to what? Ui, sorry, odd term will be negative. Ui delta x multiplied by ui prime plus delta x square divided by 2 factorial ui double prime minus delta x cube upon 3 factorial ui triple prime plus delta x to the power 4 upon 4 factorial ui 4 time differentiation plus higher order term. Okay, this is what we will get. Now if I want to write here ui minus 2, okay, so here difference is what? Suppose this is my I. So this is what this is I minus 1. This is I minus 2. This is I minus 3. Okay. So this is delta x. This is delta x. This is also delta x. So difference is what? 3 delta x. Delta x difference. So here it what will delta 2 delta x difference. So this will be equal to ui minus replace delta x with 2 delta x. So 2 delta x ui prime plus 4 delta x square upon 2 factorial ui double prime minus 8 delta x cube upon 3 factorial ui triple prime plus 16 delta x to the power 4 upon 4 factorial ui 4 time differentiation plus higher order term. Okay. Now if I write ui minus 3, okay, I wish to write ui minus 3. So this will be equal to ui minus 3 delta x ui prime plus 9 means 3 square 9 delta x square divided by 2 factorial ui double prime minus cube of that will be what? 27. 3 cube what? 27 divided by 3 factorial delta x cube ui triple prime plus 81 delta x to the power 4 divided by 4 factorial ui 4 time differentiation plus higher order term. Okay. Now what we want to find? We want to find ui double prime. Okay. This is what? This is a naught plus a1 ui plus a2, sorry, ui plus a1 ui minus 1 plus a2 ui minus 2 plus a3 ui minus 3. Okay, this is what we want to find now. Simply here we have written the expression for ui minus 1, ui minus 2 and ui minus 3. Simply from here, these values from here we will put here, okay, and see what we are getting. Okay. So simply if I put the values here, so ui prime, what I will get? Okay. So simply I want to add one point here. Whichever page I am. So ui double prime will be equal to what? Will be equal to what? A0 ui plus, from here you put the whole value. So it will be equal to what? A1 ui plus a1 delta x ui prime plus a1 delta x square upon 2 factorial ui double prime plus a1 delta x cube upon 3 factorial ui triple prime plus a1 delta x to the power 4 upon 4 factorial u 4 times prime at I. Okay. Now plus what? Plus a2 multiplied by ui minus 2. I minus 2 you replace from the expression that we have found from Taylor series. That will be equal to a2 ui plus a2 multiplied by 2 delta x ui prime plus a2 multiplied by 4 delta x square divided by 2 factorial ui double prime plus this will be what? This will be what? 8 a2 delta x cube upon 3 factorial ui 3 times prime. Oh, sorry, here minus and plus odd will be minus, no? I haven't written odd as a minus. So here odd will be minus. Similarly, here odd will be what? Odd will be minus. Similarly, here odd term will be negative, no? Odd term will be negative. Okay. Plus this will be what? 16 a2 multiplied by the term. The term will be what? Delta x to the power 4 upon 4 factorial multiplied by u 4 time prime. Plus if we want to find this term will be what? a3 ui minus this time 2, this time it will be 3 a3 multiplied by delta x ui prime plus this will be what? 9 a3 delta x square upon 2 factorial ui double prime plus, sorry, minus this will be what? 27 a3 divided by 3 factorial delta x cube multiplied by ui 3 times prime plus 81 a3 delta x to the power 4 upon 4 factorial multiplied by u 4 times prime at ith location. Okay. Now you see here and in the LHS in left hand side we have in LHS we have only u prime, u double prime at ith location. But here we have some term of ui, we have some terms of ui prime, we have some terms of ui double prime, and we have some terms of ui triple prime. Okay, these terms we have. Okay, this means what? This means what? The terms of ui will be equal to 0. The terms of ui prime will be equal to 0. The terms of ui double prime will be equal to 1 since it has one coefficient in the left hand side, and ui triple prime terms, the summation will be equal to 0. Okay. Okay. So simply I will equate this now. So first equation, what I will get from here? I will get this, 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 this. This is the terms of ui. From comparing ui, I will get a0 plus a1 plus a2 plus a3. That will be equal to what? 0. Since in LHS there is no term of ui. Similarly, this term, and this term summation will be equal to 0. So what? a1 plus 2a2 plus 3a3, that will be equal to 0. Similarly, this term a1 plus 4a2 plus 9a3. So a1 plus 4a2 plus 9a3. That will be equal to not 0. This will not be equal to 0. This will be equal to 1. But in LHS, we have the multiple of this. No, this is the multiple. Delta x square 2 factorial value will be what? 2. So this is what we got. So if we make this to the right hand side, if you move this to right hand side, what I will get? I will get it as 2 upon delta x square. Okay. The last equation, what I will get? A1, 8, A2, A1, 8, A2 on, and what I will get? A1, 8, A2 and 27, A3. So A1 plus 8, A2 plus 27, A3, that will be equal to 0. Okay. So we have what here? 3 equations, no? Sorry, 4 equations, 4 unknown. So this is what? System of linear equation. This is what? System of linear equation. This can be solved by using iterative solver, or you can solve using the direct solvers. So we can solve this using Gauss elimination, or LU decomposition method. So I will solve this problem using Gauss elimination method. Okay. So if I write this in matrix form, okay, if I write this in a matrix form, what I will get? 1, 1, 1, 1, 0, 1, 2, 3. Okay. 0, 1, 4, 9, 0, 8, sorry, 8, 1. It will be what? 1, 1, 8, 27. What are the unknowns? A0, A1, A2, A3. Okay. In right hand side, what we have? 0, 0, 2 upon delta x square, 0. Okay. This is what we have. So what we'll try to do? We will do the elimination process to try to make this into a upper triangular matrix. Okay. So we will try to make it to upper triangular matrix. So this is my first pivot element, and all the terms below this pivot element is already 0. So what is my next pivot element? This is my next pivot element. So I will try to make this term and this term as 0. So simply what I can do, I can subtract directly. No? So what I will do, I will write row 3 as row 3 minus row 2. Okay. Similarly, I will write row 4 as row 4 minus row 2. Okay. So what we'll get here? Simply 1, 1, 1, 1. This is 0, 1, 2, 3. No change. 0. Here what will get? 0. Here what will get? 0, 0. 4 minus 2, 2. 9 minus 3, 6. This will be equal to 4. This will be equal to what? 9 subtracted. It will be 18. Okay. Then what is my A0, A1, A2, A3? Okay. In right hand side, what I will get? This will be 0. This will be 0. In this term, this right hand side, this term is 0. So no change in the RHS. Now what is my pivot element? This is my pivot element, and I want to One second. 1 second. There is some mistake I have made. So the mistake what I have made. So subtraction, it will come 2. It will come as 6. Now this minus this 6, and this minus this, it will be 24. Okay. Okay. Now what I will do? This is my pivot now. Okay. Now what I will do? I will put row 4 as row 4 minus 3 multiplied by row 3 to make this term as 0. Okay. Then what I will get? 1 1 1 1. Okay, 0 1 2 3, 0 0 2 6, 0 0 0. What it will be multiplied by 3, 18, 18 minus 24, it will be 6. Here what it will come, A0, A1, A2, A3. Okay, right hand side 0 0 2 divided by delta x square. If you multiply this by 3 times, it will be 6 by delta x square. If you 0 minus by 6 divided by delta x, it will come simply negative minus 6 delta x square. Okay, this will lead to a3 equal to, this will lead to a3 equal to minus delta x upon, sorry, minus 1 upon delta x square. Okay, now I wish to find a2. That a2 will be equal to what? A2 will be equal to what? 2 by delta x square, this term minus 6 multiplied by minus 1 divided by delta x square. Okay, this will lead to minus minus will be plus, so this will lead to, sorry, here it will be 2 times, no, 2, here is it is 2 to 2 times. So this will lead to a2 will be equal to, this will be what, 6 plus 2 8, no, yeah, 8. So it will become as plus 4 by delta x square. Okay, this will come like that. Okay, fine. Now I want to find what? A1. A1 will be equal to what? 0 minus this 3 times minus 3 by delta x square from A3 and minus 2 multiplied by delta x square. That will lead to A1 will be equal to, A1 will be equal to what? A1 will be equal to, from here, this will become positive, this will become negative, minus 5 upon delta x square. Okay, this will come minus 5 upon delta x square. Similarly, if you find summation of all this is 1, so this is what, minus 1 for minus, yeah, this is 3, 3 3 3 minus 5, this will equal to minus 2. So a1 a0 should be equal to 2 divided by delta x square, which means what the value we have got. I will write directly the value. What we have got, a3 equal to minus 1 upon delta x square. A2 is what, 4 divided by delta x square, comma, a1 is what, minus 5 divided by delta x square, and a0 is what, 2 divided by delta x. I hope this is clear. Please respond. Okay, so this is how you should solve this problem. Okay, so for any problem, you can solve this. Suppose here, if there we have seen now one problem. I wanted to suppose find out this. I wanted to find this second order derivative with forward difference. So simply you can assume here also, if I add one page here, it is already added. So if you can directly assume now y, maybe I should select some another color pen. you can directly assume ui double prime is equal to a0 ui plus a1 ui plus 1 plus a2 ui plus 2. Then you write these values using Taylor series expansion. Okay. Once you will write these values using Taylor series expansion, then equate the coefficient of ui to 0, the coefficient of ui prime to 0, the coefficient of ui double prime to 1. Since we have here how many unknowns? These three unknowns we have here. So this coefficient of ui to 0, coefficient of this to 0, u prime, and u double prime to 1. Using these three equations, you can solve and find a0, a1, and a2. Okay, this is how you can find. So do you want to solve this problem here? Okay, or you will solve at your home? Please respond. Okay means what? You want to solve right now, or you will solve at your home? Okay, fine. Just give me a second. I want to drink water. Just 1 second. Now let us just revise the topic that has been additional topic that has been covered in week 5. Since we have already solved the assignment problems and the practice problem for week 5. Okay. Now just we will revise it. Then in this meeting. Okay. So you have, then he has discussed about the general procedure. The general procedure is like that, the problem that we have discussed. This is the general procedure. Last problem, whatever we have solved, where it is. This is the, so this is the general procedure to find any order of derivative with any number of points. Suppose you want to go for second order derivative is 4 order backward difference. Suppose you want to find second order derivative with 5-point forward difference scheme. In there you will have 5 points. Okay, so order of this truncation error order will increase. Like that, if you want to solve generalized method, we have already discussed. Then what? Then some discussion based on non-uniform grid. Okay. So uniform grid means what? We have discussed that uniform grid with non-uniform grid. There what he has discussed. Suppose if I have I minus x of I minus 1 equal to delta x for every I, suppose I goes from 1 to, sorry, 2 to, I goes 1 to n. Okay. So for every I, if this condition is satisfied, this means what? This means what? I have uniform grid. If this is not satisfied, which means what? Suppose if I have a like that, this is my ith point, this is my I plus 1th point, this is my I plus 2th point, similarly I minus 1th point, I minus 2th point. So this difference, if I write delta xi, this difference I write delta xi minus 1, this difference I write delta xi plus 1. So if for if for some i's, if for some i's delta xi is not equal to delta xi plus 1, or delta xi is not equal to delta xi minus 1. Oh, sorry. Then this will called as non-uniform grid. Okay. So in that case, here if I write u I prime by forward order difference, that will come as ui plus 1 minus ui divided by delta x. Now delta x will be what? Delta x will be what? This delta xi, it will be plus accuracy will be what? Accuracy order of truncation error will be what? Delta xi. This is what? If I, this is what? Forward order. If I want to write using the backward order, this will be equal to what? Ui minus 1 divided by delta x. Here this delta x will be taken. So it will be delta x minus 1, and its truncation error order will be what? Delta x I minus 1. Fine. Okay. So the accuracy may increase or decrease depending on the differences. Okay. So if I want to write for this case central difference, okay. So central difference means what? Then I need to write ui plus 1 as Taylor series expansion, that will be equal to ui. I will not do the whole part, but I am just writing small of it. ui prime plus delta xi square upon 2 factorial ui double prime plus dot dot dot. Similarly, if I write ui minus 1, that will be equal to ui plus, oh sorry, minus, odd term will be negative now, minus delta xi, not delta xi minus 1. Okay. Now if I find simply, now simply if I subtract these two equation, what I will get? I will get ui prime as ui plus 1 minus ui minus 1 divided by delta xi plus delta I x minus 1 plus the order will come as delta xi comma or delta I square plus delta of xi minus 1 square minus delta xi minus 1. Depending on the size of delta delta xi and delta xi minus 1, the accuracy may differ. Suppose if delta xi and delta xi minus 1 is close to each other, means what we are tending towards the uniform grid. In that case, it will have order delta x. Okay. And if my delta xi minus 1 is very small compared to, means what, if delta xi is very less than compared to delta x minus 1, or delta xi is greater than delta xi minus 1, in that case, this will be the accuracy, means it will be order of delta x square. Okay. In that case, this is what non-uniform grid. Then the numerical differentiation you can find using the, then he has discussed about the numerical method, numerical differentiation using, I need to add one page here. Then numerical by polynomial means what? Means what in this case, what will be the, this case, what is the case? This is the case, means what, we have some discrete points. By using these discrete points, we'll find the interpolating polynomial. This interpolating polynomial we can find either using the Newton's polynomial interpolating polynomial method, or we can find using the Lagrangian interpolating polynomial method. Once we have found out the polynomial, we can find directly the derivative at given point. Okay. Once we have the polynomial, we can find. This can be useful where, what I think this can be useful. Suppose we have some points, discrete points we have. Here we know the function value, but we want to find somewhere between, if want to find the derivative. In that case, where we do not know the function value, in that case, first we will interpolate the polynomial to find the interpolating polynomial. Then we find the derivative directly. Okay. Clear? Then he has discussed about the instructor had discussed about the partial derivative numerical procedure. Partial derivative means what? In that case, you will be what? You will function of x and y, two variables, suppose x, y, or xt. In that case, we will not have a linear grid, but we will have a this 2D kind of grid. No? This type of grid we will have. Okay, suppose this is my ith row and this is my jth column. So this will be what my, this will be I plus 1th row. This will be my I minus 1th row. This will be my j plus 1th. This will be what, j minus 1. So this is my coordinate. This is my coordinate I comma j. Okay, I comma j. So suppose if I want to find here del u upon del x, means what, in the x direction I want to find. So del u upon del x I want to find, means what, at x equal to I. Okay, this is what I want to find. So this I can write ux, or this simply can be written uxi. Okay, this is uxi. Then this uxi will be equal to, if I use the forward difference method, then I will use this point and this point. Okay, the difference I want to find the derivative in x direction. So this will be my 2 points. So this will be what, u of I plus 1. Oh, sorry, there is one mistake I think I have made. Okay, so I am just, this is my jth. Okay, so this is my j rather than row. This is j. This that way also you can assume, but so that we do not confuse, this is my I. Okay, so ui plus 1 minus ui comma j divided by this difference, means what, if it is uniform grid, then it will come as delta x. Okay, if backward difference I want to write ux I prime u prime ux prime at location some j location. Okay, ith location. So same I want to find backward difference. So I will write u I comma j minus u I minus 1 comma j divided by delta x. Okay. Simply, if I want to write u y comma j, so that then this will be equal to what, if I want, I am using forward difference, it will be equal to u I j plus 1 minus u I j divided by delta y. For if we are having uniform grid, it can be written as ui. Okay, clear? I think you have understood, na? Similarly, you can find what, uxx, that will be equal to what, at some ith location, that will be equal to what, that will be equal to del u del x, sorry, del 2u upon del x square. Similarly, u y you can find. Okay. So just revise the thing that has been covered by instructor once more. Okay. So in this class, what we have discussed? First, we have discussed. So this week 5 is what? Week 5 was the starting of the calculus part, for using the numerical method in the calculus part. Means what? Using the numerical method in the calculus part. So there first we have discussed about the interpolating polynomial. So in the calculus, whatever we have discussed, when we are going for the analysis solution, we have a continuous domain. But here we only have a discrete point. Means what? We have the function and its value at some discrete point. So what we have seen, we have tried to find out the First, we are trying to find out the interpolating polynomials to convert the discrete to the continuous form. Okay. So interpolating polynomial, first we have seen the easiest method. There we have found vendor mode matrix, which is not a well-behaved matrix. If we have this xi's very close to each other, that will lead to the determinant very close to 0. That will lead to the inverse of the vendor mode matrix, very high value, which will lead to very high value, will lead to the small change in xi's, means a small change in the points will lead to the large change in the polynomial. So that's why this is called not a very well behaved poly matrix. Okay. So to resolve this issue, not to go for this method, we have seen first the Newton's polynomial methods. In Newton's polynomial methods, we have seen how we can convert that matrix to a lower triangular matrix. Okay. So that can be solved easily using the forward substitution method. Then we have seen the Lagrange interpolating polynomial method. Then we have solved two problems using all three methods. Then we have moved towards the numerical differentiation part. Numerical differentiation, there we have seen the difference using the finite difference methods. So first we have seen what is the finite difference methods. Then what we have seen, then we have seen the how to find out the derivatives, first order accurate derivative, second order accurate derivative, using forward difference, using backward difference, using central difference, using 3-point forward difference, using 3-point backward difference. Then we have seen the second order derivatives, then second order derivative for higher order accuracy. Then we have seen the generalized procedure, how we can find any nth order derivative with some n points, whether it is forward order, or it is backward order, backward difference, or it is central difference. Okay, generalized procedure we have seen. We have also solved one problem based on we have found second order derivative using 4-point backward difference scheme. Okay, that will lead to higher order accuracy. Okay, so we have found A0, A2 like that. And we have also solved one problem for finding the derivative where we have discrete point and we have found first forward difference ui prime using forward difference, using backward difference, and using what? Central difference. Okay, so I think this is all for this lecture. Should I end this meeting? If you have any doubt, please ask. I don't think you will have any doubt. Please revise the lectures, and it will be very beneficial for this problem solving section. If you watch the lecture, then come to the problem solving session. Okay. Okay. Thank you. Thank you so much.